Greetings everyone. In this video, we'll explore multiple Aegis use cases within a single presentation. We'll delve into the source code and showcase Aegis's adaptability as a secrets management solution. For those who haven't used Aegis so far, Aegis is a SPIFFE compatible, secure, cloud-native, and lightweight secrets manager. You can browse the link here to learn more about it. And for the curious, SPIFFE and Spire provide strongly attested cryptographic identities to workloads across various platforms. Well, that's a bit mouthful, but that's the official definition from the spiffy.io website, though I'd like to summarize it without losing too much rigor, as SPIFFE and Spire help you distribute identities to workloads, or more concisely, SPIFFE and Spire manage workload identities. You can again visit this link to learn more about SPIFFE and Spire, but back to our demo. I've split this terminal into three parts. The bottom two windows will be mainly for tailing logs, and I'll enter most of my commands on the top terminal. So this system has Spire and Aegis installed on it, and we'll be deploying workloads to test how it works essentially. Let's start by seeing what we have in our cluster. We have Aegis Safe and Aegis Sentinel pods in our Aegis system namespace. And since we have Aegis Safe, I want to tail its logs here using this command so that you can see things, moving on when I interact with the system. So our default namespace is empty as expected. This is a blank greenfield deployment. There are no pods in it aside from Aegis system pods and Spire system pods. And since Aegis is installed here, let us verify if Aegis Sentinel is working as well. I'll do a kubectl exec Aegis Sentinel --Aegis --help, and it will display a comprehensive help message about how to use this command essentially. So Aegis Sentinel is up and functional. Also, when I describe the cluster SPIFFE ID for Aegis Safe, I see that it has a matching pod, which means Aegis Safe has an ID, has an SVID, and that means it can receive its workload identities successfully. The same is true for Aegis Sentinel. Since we have one pod selected instead of 0, Aegis Sentinel can also acquire its SVIDs and therefore establish secure MTLS connectivity with Aegis Safe to register secrets essentially. So now I want to deploy a pod that I call Inspector. I'll keep it alive during this entire demo, and I'll use it to check the value of secrets registered to our demo workloads. You can think of Inspector like a debug container. I'll be keeping it alive all the time so that I can inspect what's happening in my system. But the premise of Aegis was it delivers secrets to only the workloads that are associated with that secret. So how can another pod watch some other workload's secret? Well, a secret is associated only with the workload ID part of their cluster SPIFFE ID, and this is by design. So if two workloads have different SVIDs, but they share the same workload ID region in their SPIFFE ID, then Aegis Safe will be more than happy to deliver the same secret to both of the workloads. This is especially useful when you want to create different kinds of workloads that receive the same secret but produce different outputs. Or it is useful in this case when we are debugging things, like a workload might be having trouble receiving its identity, and you want to make sure that Aegis has the secret properly registered in Aegis Safe, and the root cause of the problem is not with the Aegis system, but it might be related to the workload itself maybe. But what does this install inspector script do? Well, when we look into it, it CDs into this directory and deploys a bunch of Kubernetes objects. So let's see that directory, and here in the directory, the most important one is this deployment YAML, and it points to this image as its primary workload. So let's see the code that's running inside that image file. And if we disregard this preamble and this error check, our workload in this main function fetches the secret linked to it and then displays it, and that's the only thing that it does. But how do we run this code? The Docker file associated with this image builds the code and saves it as a binary named env for environment, and then copies that env binary to the target image. So when you shell into the inspector pod and execute env, you should be able to see whatever secret is registered to the workload. So to get the secret, I have this secrets.sh utility file. And if you look into the file, it is doing exactly what I described a few moments ago. It runs env on the inspector pod using kubectl exec. But when I run it, the request hangs and I don't get a response back. Why so? Because we haven't registered a SPIFFE ID to this inspector workload yet. And since the workload cannot identify itself to Spire, it cannot establish a secure MTLS connectivity with Aegis Safe. Thus, the connection remains open without being able to receive any response. So when we execute kubectl get cluster SPIFFE ID, you can see that no identity has been associated with the workload. So let's register the IDs and see what happens after that, which is again applying a bunch of declarative manifests to define the cluster SPIFFE IDs. Here is the cluster SPIFFE ID of the inspector, and here is the cluster SPIFFE ID of the workload. They practically share the same workload section, which helps them share the same secret, and that's the whole purpose of the inspector, as I said. So let's install cluster SPIFFE IDs, and once we wait for a while, you'll see that the connection is no longer hanging, and eventually we get a response back. It says that the secret doesn't exist because, well, we haven't registered any secret yet, and that's expected. Still, after registering the cluster SPIFFE ID of the inspector can happily talk to Aegis Safe to fetch its secrets. And when we describe the cluster SPIFFE ID of Aegis Inspector, you see that we have one matched pod here against it, so it's able to dispatch an identity to that workload. Now let's add a secret and see what happens, but let's see the code first. So we are registering this secret to this workload in this namespace, and we run it and we got an OK. That's good, I guess. And when I query for the secret, I can get the secret on my terminal just fine. Now let's delete the secret, which is done by specifying this workload name. So when I run the command, it removes the secret from Aegis Safe, and it's all done. Now let's add a workload with Aegis Sidecar installed next to it to test it out. And again, if we check this file, it's similar. We are installing a bunch of Kubernetes manifests. So let's see what we are deploying to the cluster. So this is our main workload, and this sidecar will share the secret with the workload when the secret is available. If we check the source code of the main workload, you'll see that it tries reading the secret file that the sidecar is supposed to share with it. And if it can find the file, it will display the contents of the file. And if it cannot, it will print an error message, and it will retry in 5 seconds in an infinite for loop. So let's deploy this workload, and when I do a kubectl get po, you'll see that this demo workload has 2 pods because it has a sidecar. And when I tail the logs of the workload, I see that I cannot fetch the secret yet because there are no secrets registered. So let's register a secret to this workload by running this register plain secret.sh. Again, when I check the secret, I see that it is there, and soon enough it will reflect to the workload logs too. You can also add multiple secrets to a workload if you want to. So I have this register multiple secrets to show you how it is done, but it is very similar. Let's view what it has first. It is similar to the single secret version with one difference, that is this -a flag. And -a means append. So instead of overriding the current secret value, you append to it. Let's see what happens when you do that. I run the script and I got 2 OK responses for the 2 appended secrets. And when I get the secret, I now have an array of values instead of a single secret value. So the result will reflect momentarily to the workload too, just like this. Aegis Safe also allows you to encrypt the secrets. Encrypting them will enable you to store them in places like source controls and artifactories without risking their exposure. And here's how you encrypt a secret. The syntax is again similar to what we have seen so far. So you provide a secret to encrypt, and this -e flag means to encrypt the secret and give the encrypted output. So remember that there is no way to decrypt a secret from Aegis Sentinel, and that is by design. The only entity in the system that can read the secret is the workload that is allowed to see the secret. So nobody else, not Sentinel, not Safe, can give you the secret back. It's only available to the entity that has been given access to this secret, which is this workload in this case. And we have this base64 hashed version of our encrypted secret. So we format the encrypted data in base64 to make it easier to send it through emails or put it into API payloads or save it in like source controls, because storing binary data in textual format is easier when you use base64 as an encoding form. But to be clear, the data is not just encoded, it is first encrypted, then encoded into base64. So there is no way to decrypt this data without knowing the private key. Since we have encrypted this secret, now let's register the encrypted secret to our workload. For this, I'll change this secret environment variable, source it, and use it elsewhere. So let me delete the original secret linked to this workload first to have a clean slate. And let's check the pods to see that the workload is healthy, and it is. And then I'm going to register an encrypted secret to my workload. And the script to do that is like this. We register the encrypted secret that we just added to this env file and sourced it into this workload in this namespace. This -e flag means that the input value is encrypted, and Aegis Safe will need to decrypt the value before it registers it to the workload. So I'll tail the logs of the workload again and then register the encrypted secret to the workload. I get an OK, and it's here when I list the secret, and the change will soon reflect to the workload as well, and there it is. So far we used a workload that leverages Aegis Sidecar. Now let's use a workload that directly talks to Aegis Safe using the Aegis Go SDK. So the code to install the workload is similar. We cd into a folder and deploy a bunch of manifests. So let's see what we have in this workload SDK folder. We have a deployment, and this is our main workload that interacts with Aegis SDK. So let's see its source code. I'll collapse these error checking guard clauses again to gain some screen space, and the code does fetch the secret that this workload is associated with using Aegis SDK, which this Sentry module is part of the SDK actually. And then it displays the secret's contents if it finds such a secret, and if it doesn't, it will display a warning message. And we repeat this every 5 seconds forever as usual. So this sentry.fetch is all you need to get the secret that's bound to the workload. The rest of the heavy lifting has been abstracted inside Aegis SDK for you. So let's deploy this workload, ensure that the pods are up and running, and then tail the workload again. Now I'll register a secret, and we'll see that the workload will get the secret quickly. So I got my OK, and when I query the secret, I can see it is here. And after a few moments, I can see the secret registered to the workload as well. I can register more than one secret too to this workload, of course. This SDK use case will behave identically to the sidecar use case because the sidecar also consumes the SDK behind the scenes. So let me delete the secret, and we'll see that the workload cannot get the secret back. Let me delete the workload to switch to our next demo with a clean slate again. This one is interesting. I want to interpolate my secret into environment variables in the workload, but since the environment variables are in memory, they must exist before the workload starts its lifecycle. And we have a Kubernetes primitive designed just for this use case, and that is init containers. Aegis has a special Aegis init container that when you attach it to a pod, it will wait for the secret to be available for the workload before it lets the main application to start. So let's see how that is done. Again, I'll show the source code of this script, which deploys a bunch of Kubernetes objects again. And one crucial object that is deployed is this secret manifest. It's an empty Kubernetes secret, and once we register a secret to our workload, this Kubernetes secret will be dynamically populated, and to do that, Aegis Safe will act similarly to a Kubernetes operator and modify this Kubernetes secret by interpolating key value pairs onto it. So to be clear, Aegis Safe is not an operator, but it functions similar to the operator. Maybe in the future it might turn into an operator when things get more involved, but at the moment what it does is just to find this secret and update its data. And our deployment uses this image, and the source code of the main application of the image in our pod is Similar to what we have seen so far, in an infinite loop, we print the environment variables bound to the container every 5 seconds, because this time we are injecting environment variables to our workload. And how are those environment variables bound to the container? Well, they are injected into this environment section of the container as secret key references. So let's create our workload and then list the pods to see what our workload looks like. So this is pending in the init stage because the Aegis init container has not yet detected any secret attached to this workload. So let's register some secrets to our workload and see how things pan out. But before that, I want to execute this kubectl get po with a --watch flag to see how the workload initializes in real time. And I'll execute this register Kate's secrets script. But let's see what we are executing first. So what we do here is we take this secret and we pass it through this Go template transformation. And for each key value pair in this transformed JSON, we add a value to the empty Kubernetes secret object tied to this workload's main container. So this -k flag indicates that we don't want to just transform the secret, but we also like to modify an actual Kubernetes secret object to reflect our changes. So let's run this. And as soon as we get an OK acknowledgement, you'll see that the pod has started initializing. And in a few moments, it is ready and running. When I tail the pod logs, it correctly displays the environment variables, and when I check the Kubernetes secret, you can see that it has 3 data items corresponding to these values here. To double check, I can list the secret here, and this approach is handy for like legacy workloads where you don't want to alter the code for the workload's application, or you want to induce as little changes to your system as possible. In that case, you can interpolate an Aegis secret into a Kubernetes secret and let your workload consume it however it used to consume its secrets before, either as a file mount or an environment variable that's mapped out of that secret file. But I'd recommend using SDK or the sidecar approaches whenever possible, since they provide a tighter security boundary and they are more efficient to use. So let's delete this secret and this workload again for a few more additional demos. I'm going to install a workload that uses SDK this time, as it responds faster than the sidecar one. I verify that the pod is running and it is running okay, and then I'll tail the logs of the workload pod. Then I'm going to execute this register secret JSON file. But let me show the contents of it first. It is similar to other secret registration scripts with one difference, which is this -f JSON flag. And with this flag, Aegis Safe will ensure that the secret it displays is a valid JSON. So we will do this transformation and interpolation here. But if the result is not a valid JSON, the transformation will be discarded, and Aegis Safe will dispatch to the workload this original secret value, not this transformed one, if the transformation results in an invalid JSON. Otherwise, it works similar to the things that we have seen before. So let's run this and see how it works. And yes, I get a transformed value JSON as a string, and the workload received the same value too. Let me delete this secret and do the same thing, but now in YAML form. When we use this -f YAML flag, after transforming this secret into JSON using this template transformation, it will transform the end result into YAML. So if everything is a valid JSON here and here, you can expect the end result to be a valid YAML. That's especially useful if your workload expects a YAML or like a YAML-like configuration file to operate, so that you don't have to transform it yourself. The transformation will be already done for you. So let's see it in action. Register secret YAML. And yes, when I list the secret, it's now in YAML form with all new lines and all, and it will reflect to the workload logs as well soon. And there it is. As you see, it is more YAML-ish than JSON-ish. So let me delete this secret to show you the third and final option in this format section, which is format type none. So let's see it. And this option allows you to do free-form text transformations on your secret. So when you do the transformation, Aegis Safe is not going to do any JSON or YAML validation, and it will transform this secret into an arbitrary string value using this template that you provided. So the only requirement is this secret value you enter here to be a valid JSON, and your end result will be the output of this template transformation. So let's do that to see it in action. And we see this arbitrary string on the workload's logs. And when we view the secret using our inspector pod, we also see this arbitrary transformation here. This is not a JSON nor a YAML, it's just some arbitrary freeform text. And this is also the end of this quick demonstration of some of the capabilities of Aegis. You can always consult the Aegis website and Aegis GitHub repository for more information. Yet as far as this demo goes, that's all there is to it. Hope you like it, and I'll see you in the upcoming Aegis videos.